Hey, today we're going to talk about the patterns that you can see when you're dividing with decimals. So before I get to showing some of these decimal patterns, it helps to look at some patterns in whole numbers. So I'm going to start with whole numbers, 24 divided by 4, just like over here. And we know that how many 4s fit into 24? Well, 4, 8, 12, 16, 20, 24. That is 6 fingers. 6 groups of 4 can fit in 24. So what happens when you are doing this with whole numbers? Let's make the dividend larger. I'm going to make it 10 times larger. I know it's 10 times larger because each of these digits have moved one place value up. So now 240 divided by 4. So I have 10 times as many items to divide. For example, I got 24 cookies and I'm dividing them onto 4 plates. Each plate gets 6 cookies. But if I have 240 cookies, that's a lot of cookies. And if I'm still dividing them by 4 plates, I have more cookies to divide, so my quotient is going to be a lot bigger. In this case, it's going to be 10 times larger, because whatever change I make to the dividend, if the dividend gets 10 times larger, the divisor gets 10 times, or the quotient, gets 10 times larger as well, because I have more cookies to start with, so more cookies go on each plate. And this pattern will keep continuing. If now my dividend, now I have yet 10 times more cookies, then my quotient is going to be another 10 times larger. I can get 600 cookies on each plate. I'm going to need some big plates. So that's what happens when we change the first number, which is called the dividend. So over here, I have 24 divided by 4 again, and that, as we know, is 6. But here I've changed the dividend in a different way. Here, the dividend is getting 10 times smaller. Do you see that? How each of these digits go down a place value? So that the 2 moves from the tens place to the ones place, and the 4 moves from the ones place to the tenths place. So now it's 10 times smaller. So now I have 10 times fewer cookies. It's kind of weird to think of 2 and 4/10 of a cookie, but that's what we get when we go to decimal numbers. So if I only have 2 and 4/10 of a cookie, if I'm trying to put them on 4 plates, well, I don't even have 4 whole cookies. So I know that my quotient is going to be less than 1 whole. I've got a picture to show this, actually. So I have 2 wholes here. 1, 2 wholes. And then my 4/10 is shown right here. That's 2 and 4/10. And then I've divided them into 4 groups. So these lines divide it. So this is group 1 here. And then from between these 2 maroon colored lines is another group. And then that's another group, and then this is my last group. So I have 4 groups. How many is in each group? Well, I have 1, 2, 3, 4, 5, 6 columns in each group, and each column is 1/10. So here, my quotient is 6/10. So you can see when I have 10 times fewer cookies to share onto these 4 plates, each plate is going to have 10 times fewer cookies on it. So you only get 6/10 of a cookie on each plate. I can continue this further and shrink the dividend yet smaller to do, let's do 24 hundredths divided by 4. So now I've even got a smaller amount. So this is 10 times smaller dividend. And you guessed it, my quotient is going to be 10 times smaller as well. So instead of 6/10 of a cookie on each plate, now I only get 6/100ths of a cookie. I mean, I only had 24 hundredths of a cookie to start with, right? So that makes sense that I only have 6/100ths of a cookie on each plate. In fact, if I write them out with their place value names, 24 hundredths divided by 4 plates, I get 6 hundredths. And that makes sense because 24 divided by 4 is 6. 24 hundredths divided by 4 is 6 hundredths. So right here, I'll write the pattern that we just learned. When the dividend gets 10 times larger, the quotient also gets 10 times larger. And that works vice versa. When the dividend gets 10 times smaller, the quotient gets 10 times smaller. As the dividend grows, the quotient grows. As the dividend shrinks, the quotient shrinks as well. So on the next page, we'll see what happens when we change the divisor, that number in the middle of the equation. Again, we'll start with 24 divided by 4, that is 6. But now 24 divided by 40. So we're taking our 24 cookies and we're dividing them by 40 plates. Wait, that's more plates than cookies. So as you might have guessed, we're not going to have a full number of cookies on each plate. When we change the divisor, we're making the divisor 10 times larger. That means the quotient is going to be 10 times smaller. You see, changing the divisor has an opposite relationship with the quotient. That makes sense because the more groups you have to make out of this, the fewer go in each group. So if I still have only 24 cookies to share, but now I've got to divide them into 400 plates. I've got to split those cookies in tiny pieces to make sure a little bit of each of the cookies gets on each of those plates. So again, I'm making the divisor 10 times larger. That means the quotient is going to be 10 times smaller still. So only 6/100ths of a cookie goes on each plate because I have so many plates and only 24 cookies. So now let's look at making the divisor a smaller number. Here we increase the divisor. So if we make the divisor a smaller number, now this is one of the reasons why it's difficult to think about decimals, because you can't really think of this as 4/10ths of a plate. That seems a little odd. But we can think this division situation, 24 divided by 4/10ths, it means how many 4/10ths can fit in 24 holes. Well, if I count by 4, it takes 6 4s to land on 24. If I count by 4/10ths, 4/10ths, 8/10ths, 12/10ths, 16/10ths, 20/10ths, 24/10ths, I'm still only at 2.4. I have to get all the way to 24. 28/10ths or 2.8, 32/10ths, 3.2, 3.6, 4, 4.4, 4.8, 5.2. This is going to take a long time, right? I have the groups I'm dividing into are 10 times smaller. Since this number is 10 times smaller than that, it means I can fit many more of the divisor into the dividend. So when I change the divisor, make that 10 times smaller, the quotient gets 10 times larger. Changing the divisor has the opposite effect on the quotient. Do one more. I'm going to make this divisor even smaller, 4/100ths. And that's going to make the quotient, again, 10 times larger still. So our rule for changing the divisor, when we make the divisor 10 times larger, it makes the quotient 10 times smaller. So changing the divisor has the opposite effect on the quotient. Before, when we changed the dividend, changing the dividend changes the quotient as well. So as the dividend gets larger, the quotient gets larger. As the dividend gets smaller, the quotient gets smaller. But when we change the divisor, making the divisor larger makes the quotient smaller. Making the divisor smaller makes the quotient larger. So changing the divisor has the opposite effect on the quotient. So let's just practice this to summarize what you've learned. If you're trying to do 5 divided by 3/10ths, one way you can think about it is, okay, let me just think about it as whole numbers. 5 divided by, or 15 divided by 3 is 5, but this divisor, this is 10 times smaller. So that means that I can fit more of these inside 15. So my quotient is actually going to be 10 times larger. And 15 divided by 3/10 is, in fact, 50. Or what about if you've got to do 1 and 5/10 divided by 3? Well, again, you can think of them as whole numbers. 15 divided by 3. Well, 15 divided by 3 is, again, 5. But here, the dividend is 10 times smaller, meaning I have fewer things to divide. So however we change the dividend, that has the same effect on the quotient. So the quotient is going to be 10 times smaller as well. 5 divided by 10, that's 5/10. So 1 and 5/10 divided by 3 is 5/10. And lastly, what about if both of the numbers are decimals? Well, in this case, this is actually the easiest situation. If I think about these as whole numbers, 15 divided by 3, still 5. But this dividend is 10 times smaller, which should make the quotient 10 times smaller, except the divisor is also 10 times smaller. But wait a minute. What happens when you change the divisor? It has the opposite effect on the quotient. So look, this divided by 10 and the multiplied by 10, they basically cross each other out, and you just have the same quotient. How can that be? Well, look, you're changing both of the numbers the same amount. 5 3s fit in 15. 5 3/10 fit in 15/10. See, if I write these again with their place value name, 15/10 divided by 3/10. We're dealing with tenths here in both cases. 15/10 divided by 3/10, and you're going to fit 5 though in each. So this is actually the easiest situation when you have the same number of decimal places here. You can just think of these as whole numbers, and you're going to get the same quotient.